Good afternoon, ladies and gentlemen. In this short video, I'll be doing the preparation problems in Chapter 7 for Practice C. And these are on page 264, number 18 and 19. Before we do that, I want to make sure you guys review. This is from the summary page for Chapter 7, and that is Newton's law of universal gravitation. Okay, so what is it? Gravitational force. There's always a force between two bodies. So if I have two people sitting next to each other on desks, there is a force between them, an attraction. Of course, you know, there's another kind of attraction between two students potentially, but there's an actual gravitational force. And it has to do with their mass of each body, the mass of the first body times the mass of the second body, divided by the distance. We call that the radius, the distance between, and you're going to measure it from the center of one body to the center of the other body. That's the radius squared, the radius squared, all that times a constant. Okay, so the constant is this 6.673 times 10 to the negative 11. No, I have never memorized this one. I haven't used it that much. And it's Newton meters divided by kilogram squares. Should be an open parentheses there. All right, so let's take a look at the problem. And the problem number 18 says, the gravitational force of attraction between two students sitting at their desks in a physics class is 3.20 times 10 to the negative 8 newtons. One student has a mass of 50 kilograms and the other student has a mass of 60 kilograms. How far apart are the students sitting? All right, so remember, I'm always going to give you guys points for just giving me the given. All right, so here we go. I drew a picture. Here's one student, here's another student. The mass of one is 50 kilograms, the other one's is 60 kilograms. We want to know what the R is between them. What's the R between them? And they tell us what the gravitational force is. And you know the units of force is newtons. Now I dropped the 0, but you can worry about that at the very end and think about how many significant figures they gave you, etc. Okay, so the first thing we have to write down is the equation. What is that long equation? Well, the gravitational force is the big number G times M1, M2, all divided by R squared. Now, I've been really serious on you guys always solving for the variable first. You're going to see why, because these problems are going to get a little hairy. They're so straightforward that just the numbers are going to be really big. So if you solve for the variable, it makes life much easier. Okay, so I multiply R squared to both sides and then divide FG. R squared to both sides. These cancel out here. And all this stuff comes down there, so the R squared is by itself. So I end up with R squared is G, M1, M2, all divided by the gravitational force. And remember, that gives me R squared, not R. So then eventually I have to square root it. All right, so you're going to have, and usually the book will tell you, or somewhere in your test, it will tell you that the number of G, here I'll write it, G is 6.673 times 10 to the negative 11. And what are the units? It's Newton meters divided by kilogram squared. All right, so you know I'm going to write it underneath because this is going to get kind of big. All right, so R squared 6.673 times 10 to the negative 11. I'll write the units down. You should do the units at least once. Then you'll be convinced that it's all true. I'm going to put here kilogram squared. All right, and then M1 is 50 kilograms. 50 kilograms. M2 is 60 kilograms. All right, so do we take care of our numerator? There it is. Okay, so notice I've got kilograms times kilograms and I have kilograms squared on the bottom. Well, that took care of the kilograms. The kilograms cancel out. Now I've got the FG, and they told us the FG is 3.2. I'll put it over here. 3.2 times 10 to the negative 8 newtons. And you'll see that my newtons cancel out, and I'm left with meters. Meters squared. Oops, this is meter squared, no? It should be meter squared because I'm going to be square rooting it. Check that. Meter squared. Okay, so let's do this. That's R squared. Now, here's where I want you guys to get really good at using your calculator, because I have to multiply all that and divide it by all this. And the secret is parentheses are your friends. Okay, so right now we only have one number in the denominator, not a big deal. So I'll go ahead and multiply with the numerator and then divide it by the denominator. But sometimes I do the denominator first and then I invert it and just multiply it by the numerator. You'll see later what I mean by that. Okay, so here we go. I've got 6.673 times 10 to the, use a little caret, and make sure you guys can see that. I use this little caret right here for the exponent, to the negative 11. Okay, then I have to hit this button to make it go back down, times 50 times 60. All right, I'm just gonna go ahead and give me the numerator there. There's my numerator. Ooh, it's a really small number. Now I gotta divide that by another small number. So here I'm gonna use parentheses because I want it to be 3.2 times 10 to the negative 8. You will not get the same answer if you don't put the parentheses there. Minus 8. Oh, rats. I have to go down. Oh, I'm not sure if that's gonna. Okay, still learning how to use this calculator. There we go. Times 10 to the negative 8, and I have to make it go down, then close the parentheses. There we go. All right, and I get 6.25. All right, let's write that down. 6.2559375. But that's meters squared, so I still need to square root it. So I'll take this and I'll do second for the square root and second of the answer. And I get 2.5, so the radius is 2.5011, so 2.5 meters. I'm just checking mine. Yep, that's what it is. So 2.5 meters, which by the way is about 8.2 feet. In case you cared, it's about 8.2 feet. All right, so that's how far they're seated. So again, this is just an example of having to use the equation. What is the equation? The equation for gravitational force is the constant G, which is a big number. Actually, it's a really small number, 6.73 times 10 to the 11, times m1 times m2, all divided by the distance between them squared. So we just plug that in, and then we had to take square root. All right, let's do the next number. The next one is number 19. Number 19. If the gravitational force between an electron, and the mass of the electron is small, 9.11 times 10 to the negative 31 kilograms, and a proton, which is 1.67 times 10 to the negative 27 kilograms. And a hydrogen atom is a really small amount of newtons, 1 times 10 to the negative 47 newtons. How far apart are the two particles? So how far apart is the electron from the proton? Okay, so again, you want to give me the given. Always give me the given. And the reason I want you to give me the given is I promise you, it just sort of jumps out at you what the answer is. After you write the given, then you write the equation. Okay, so there's the mass of my electron, the mass of my proton. Here's the gravitational force between the electron and proton, and we want to know the distance between them. All right, so the first thing we do is we write the equation down. The equation is, and you do have to give me first the first equation, always, each problem. So I got G, the big G, M1, M2, all over R squared. And just like in the other problem, from here I can do a switcheroo, multiply and then divide, and you get R squared is equal to G M1, M2, all over the gravitational force. All right, so that's what we need to plug in. So let's do that. Okay, I'm gonna write it over here so I have more room on the page. R squared is equal to G. My big G is 6.673 times 10 to the negative 11. All right, and after you've done that, well, I'm gonna go ahead and write down the units. Newtons meter squared all over kilogram squared. All right, times the mass. And now here's what I mean by hairy, because you really need to use your parentheses, kilograms, and the next one. Make sure that, okay. And the next one, which is 1.67 times 10 to the negative 27 kilograms. Okay, there's my numerator. All that divided by, now the kilograms is on the downstairs, down here, kilograms squared. So kilograms cancels out with my kilograms squared. And I have the newtons is going to cancel out with when I write down the newtons, which is 1.0 times 10 to the negative 47 newtons. Okay, so my newtons cancel out and I'm left with meters squared, which I will square root and become meters. All right, so this is where I want you to make sure you practice on how to do this with calculators, on your calculators. Many students said it all correctly, but they don't get the right answer because they never learned how to use their calculator properly. So I'm going to go ahead and multiply everything in the numerator. Then I'll divide it by this guy, but I'll have to put it in parentheses. All right, so hoping that I copied everything down correctly. Here we go. Let's see, how can I do this over here? There we go. Okay, 6.673 times 10 to the negative 11, and I have to bring it down, times 9.11 times 10 to the negative 11, bring it down, times 1.67 times 10 to the negative 27. All right, I'm just going to stop there. There's my numerator, bring it down and enter. Okay, so that's my big numerator, a huge thing. Just in case, I'll write it down. 1.0152 blah, blah, blah times 10 to the negative 47. 47, okay. And just in case. Now I'm going to say, please divide that by, and I'm going to use the parentheses. Now here you probably make a mistake because 1 times 1 divided by is going to give you the same thing, but it may not be 1. So 1 times 10 to the negative 47. Bring it down. Okay, and there's my r squared. So my r squared is equal to 1.015 to 1, etc., meters squared. So I need to square root it. Let's do that. Give me the square root of that answer. And I get 1.075. See, 1.075. I just want to make sure I got the same thing before. And I did. All right, so I got 1.0075764 meters. Okay, now we need to worrying about how many significant figures. So they gave us, here we go, they gave us the most that they ever gave us. There's 3 significant figures here, 3 significant figures here. There's only 2 significant figures here. So this could be, and again, with you guys, I'm not going to be picky. This could be R is equal to 1.01 meters, yeah, or it'd be about 1 meter, 1.0 meter. And that's it. Okay, so again, this was just another example of how we use the equation of gravitational force, which is using the gravitational constant times m1 times m2, all divided by the square of the distance between them. And the next video I'll be doing for the practice D. All right, see you next time.